as you know, there are many different approaches to try to explain consciousness in terms of information. IIT, David Chalmers, Global Workspace, others. But I'm focusing on something which is probably not so familiar to you, which is using these quantum information. And of course, in this approach, it's a little difficult, like in a meeting like this, you know, there won't be too much focus on quantum mechanical approaches. It's a little bit like a French approach still. The most well-known is, of course, Penrose and Hameroff. So I think what I'll do today is to focus a little bit like a tutorial in the beginning, just so what you will actually hopefully experience. So this is your bonus for coming so early. So as the time was so short, what I'll try is that you will, after this, like roughly half an hour, you feel you'll understand quantum mechanics better than you did before. For those of you who already understand quantum mechanics, I apologize, because then you'll probably be bored, but let's see what happens. What I will also mention briefly is about the new fundamental notion of active information, which the physicist David Bohm suggests would actually apply even at quantum level, but other levels. And finally, you will get a glimpse of how active information might explain our knowledge of qualia and consciousness. This is actually from a colleague, Ron Chrisley, who's one of the few people who have looked at these approaches. And maybe in some ways, I think my talk could be a kind of counterfoil, let's say, to illusionism or this whole idea that consciousness might exist. I think my general point would be that often people who think we can explain consciousness, let's get rid of it, they still presuppose a fairly traditional view of the physical world. But of course, then the scientific approach would have to look into quantum theory relativity for a general view. And this is in a way what I would say that in consciousness studies, we need a scientific metaphysics. And what I mean by that is a general framework that is implied by our best theories of physics, quantum theory of relativity, and the special sciences. So, and that doesn't mean that consciousness, therefore, is reduced to quantum mechanics or anything like that. But I think we have to get our framework right. Otherwise, our discussion about consciousness is exactly the same that it would have been in the 1800s, you know, or whenever classical physics was ready. And so let's see what we might get here. So in some ways, I'm just want to introduce some, if you like, new ideas in physics, and then see what sort of how we might be able to make use of them. And of course, we've been writing about this quite a bit. And so yes, okay, let's go. Now, I would suggest that a good candidate for this kind of general framework would be Bowman-Hiley's implicate order program. The implicate order is something they actually developed already in the 1960s with Penrose. The idea there is that quantum features such as non-locality imply that we cannot no longer think that space-time is fundamental, and the only relations in physics are not spatial relations between material objects and space-time. Actually, what we need to combine general relativity quantum mechanics is a deeper level, something that John Wheeler called the pre-space, and Bowman and Hiley called the implicate order. And actually, in June, they started a new program, an ERC synergy grant, like 10 million euros, where it's called Universe Plus, where people have roughly the same kind of approach. They're trying to look at the deeper level in physics, and out of which then space-time will be emergent, material object will be emergent. And hopefully you might get like quantum mechanics, general relativity as special cases. Whereas if you just try to put them together, you get serious contradictions. But I'm not going to talk about that so much. I just say let's keep it in mind that the Cartesian res extensa explicate order is not all there is. There may also be something you might call the implicate order with properties like non-locality. And maybe there's a sense in which Descartes was right, because by saying that consciousness doesn't live in res extensa, who knows? I mean, maybe he was right. What he was maybe wrong was to say that matter can be identified with res extensa. But anyway, I just leave that as a comment that actually Descartes may not be so bad as we are often told in every philosophy of mind textbook. Okay, but I'm going to focus on something much more concrete and simple, which is known as the pilot wave or ontological interpretation of quantum mechanics, and where we get the new notion of so-called active information. And this is something like Bohm suggested already in the 80s. I was then in the UK interacting with him. I did my PhD on these topics, so I've been going along working on these ideas from for a long time. But the proposal there is that whether we could use this new information in quantum mechanics for things like mental causation, perhaps even for consciousness. Okay, but to do that, just anticipating that people are not familiar, instead of just going to the nitty-gritty, I'll do a very simple reminder, a tutorial about quantum mechanics. And the nice way to do it, in the old days we always did that with the two-slit experiment, which is a very visual thing. And so I'm just going to tell you how three aspects: ordinary classical waves, ordinary particles, and then quantum objects. You have to wait for the third part when it gets perhaps, hopefully, exciting, okay? Okay, classical waves. So you see, if you put classical waves like water waves, but could be light waves, through a slit that's much larger than a wavelength, nothing very dramatic happens. However, if this slit or hole is, sorry, it should be smaller, I made a mistake there. So if you propagation of waves through a slit much smaller than wavelength, you will get actually this kind of diffraction. So the wave will bend. And then when you put two slits together, you have two waves with diffraction, and when they meet, they will interfere. So at some points, they will make each other stronger when they're in the same phase, and if they are not in the same phase in a certain way, they will cancel each other out. And so this is actually a photograph of water waves in two slits. So waves add up in some directions, and they cancel out in other directions, okay? Hopefully familiar to most of you. But if not, here, this is the basic features of wave motion. And you see more schematically what happens with waves is then that we get these interference fringes or patterns on the screen, and some areas where you get a lot of waves and others where you get nothing at all. So interestingly, even if you put two light beams together, you will get darkness if their phases are different in a suitable way. Okay. And then when we have those stripes, many stripes there, that is called an interference pattern, interference fringes. And for a physicist, interference is a signature of a wave. It's telling them a wave was here when they see something like that in any experiment, okay? All right, moving on, let's just take ordinary particles. This is where usually everybody is with me, even our students, even philosophy students understand this much, so this is not the difficult part. So if you're shooting two bullets through these two holes or slits, you will get two stripes there. You can try it if you don't believe, but I guess most of you would agree that there's nothing very crazy about this. And so now we get to the quantum objects, for example, electrons, and we can ask what happens if you pass electrons through the two slits. And the electron was initially assumed to be a particle, it has mass and charge, this could be measured. So, physicists thought, well, they must be like little bullets. I mean, and the Newtonian mechanics was what there was. So this was the way physicists expected the electrons ought to behave if you put them into this kind of situation. But actually, this is what the experiment shows. So you get those many stripes. And so I won't go into all the details, but just notice that. And we could ask, well, why do the electrons one by one form a pattern of many stripes rather than just two, right? Why? And you see, if you look at this, well, it's a wave pattern that we get there. So there's something wave-like going on here. And we can say that they actually form an interference pattern. And we even get that pattern if the electrons enter the slit system one by one. And here's a picture of an actual experiment. So I guess in the A, there is just like 10 of them, and then more and further. When they keep going one by one, you can see the pattern, and here you can see it very dramatically. So this is very crazy. Like, it's almost like, imagine I make two holes to the table, and I start dropping sugar. I expect to get 2 piles. This is what the physicists thought that you'd. But with the electrons, I would many piles of sugar. So here's magic. So it's not just the magic of consciousness, it's the magic of quantum mechanics here. And this is, of course, being thought, Feynman thought, no way we can ever understand what's going on here. And you see, I won't go into it, but you might say, well, let's see what happens, but there's the uncertainty principle, which prevents us from actually observing the little thing is. And therefore, it's not as easy to solve as one might think. Now, this is known, of course, as a wave-particle duality. So an individual system exhibits both the particle properties. As we saw, it arrives at the detector like the photographic plate at a single spot, like any good particle would do, right? But also there are these wave properties, because the place where the spot appears is constrained by the mathematics of wave behavior. It's got, instead of just making 2 piles, somehow it's the mathematics of wave that tells you you can calculate this pattern. And so each individual has to have a wave property. How would it else know to obey, select one of the allowed places in the interference pattern rather than be, if it was good old Newtonian particle, there would be just 2 areas, okay? And you see, there's still no commonly accepted way to explain the 2-slit experiment, let's say, for electrons. I mean, it's 100 years. I think 26 is going to be 100 years from the Schrödinger equation, for example. And of course, I mean, you may know there are all this number of interpretations. There's the good old Copenhagen view. There are pilot waves. There's the many worlds, spontaneous collapse, cubism, actually many more. If you go to Wikipedia, then you can really inform yourself of all the interpretations and their properties. And of course, in my half an hour, I can't go through all of them. So we look at one of them. And why? Well, it does provide an explanation. Each interpretation has its problems, so does this one, but it has some advantages. And as a bonus, we might get even something relevant to understanding mind and consciousness. So let's go for it. So one of the interpretations, this de Broglie-Bon, it was actually invented by Louis de Broglie in the 20s, independently rediscovered by David Bohm, who made it more consistent. And you see, in here you actually say, well, the electron is a little particle. You're assuming that, but it's always accompanied by a new type of quantum field which guides it. This is why it's called a pilot wave. You see, the electron will go in through one of those holes, but the pilot wave goes through both, and there's interference. So the wave patterns after the interference will be different whether or not 1 or 2 slits are open, and then the electrons will also be guided to obey this wave pattern. So for example, where the pilot wave has 0 amplitude, the electron is not allowed to go there. So we have kind of an explanation here. And this is pilot wave. Bowman highly call it also the ontological interpretation, because it's trying to tell us what an electron is. And the way this works is that one just assumes that an electron is a particle which has a well-defined position and momentum at any given time, and it's accompanied and guided by a field psi which satisfies the Schrödinger equation. So in that sense, this is like ordinary quantum mechanics. We're not starting with a new equation or anything like that. We're using the Schrödinger equation, but what de Broglie and Bohm discovered is that you can actually construct a model by doing certain kinds of things. And just for, if you read popular quantum mechanics, this slide is for you. So in this model, it's not particle or field, which you will learn in every, almost, even textbooks. It's not a field which collapses into a particle. There is no collapse of the wave function in this model. It's not a field which branches into many worlds, like people like Everett and David Wallace would say. It's a particle and field. Or Bohm, as Bohm would like to, in his holistic way, he would like to say, it's an inseparable union of a particle and a field. Okay? And this is a slide made by Basil Hiley. Basil and I have collaborated since 91. And from here, well, it's a little bit small here, but anyway, for those of you who are interested in the technical details, so the magic of the Bohm theory is that you write the wave function into so-called polar form. R is the amplitude of the wave, S is the phase. You put it in the Schrödinger equation, you get two parts where the real part gives you this kind of equation, which almost looks like classical physics with an extra term Q. So this is why it's called Hamilton-Jacobi equation is one way of doing classical mechanics, but the quantum is modified with a Q. And it's this quantum potential that is the exotic thing here. And so a potential can be understood as a bit like a mountain. So here we are looking at these are the two slits, and the electrons are coming from those holes toward you. And they don't want to go here because the potential is very high, the mountain is very high, and you can see it in this picture, nobody goes there. They like to go into those trajectories where it's nice and you can be lazy, you just move along. And surprise, surprise, we actually get here these interference patterns as a result of this. So these are possible trajectories for a particle, and a single particle will select one of them depending on where it started over here. And where it started depends, there's a random process like a hot filament which is the source of those particles. So just very quickly, this is one way of, this is why we say, well, in the Bohm theory, you can provide a nice visualization, explanation of the greatest mystery of quantum mechanics, the two-slit experiment, okay? But what Bohm himself later on got interested, when he got more interested in things like mind and consciousness, he also felt that, well, what's this strange potential? Because here you can see, we look at it in more detail, but you can see it also in this picture, that the R is the size of the wave, and it's in both in the denominator and the numerator. The size cancels out. Here, size does not matter. So what does matter? It's only the second spatial derivative here, which is the curvature of this wave. The form, if you like. And the form, from form we get the into information. So we could argue that the pilot wave interpretation implies some radically new ideas about the nature of these quantum mechanical processes. And something that Bohm himself emphasized, that it proposes that the new type of holistic active information plays a key role at the quantum level. Which then we could say this involves a radical change in what we mean by physics and the physical. Perhaps even opening up new ways of tackling the traditional mind-matter problem. A lot of my work has been trying to spell this out. And you see, in particular, information can now be seen as a new fundamental category in physics. And this is not Shannon information. It's not information for us. This is somehow information that is there independently of human beings. It's kind of a realist view of information. Information as objective commodity, doing things in the world, making things happen, okay? And Bohm himself, proposed that this quantum information, this what we could call Bohmian quantum information, because there are other kinds of quantum information, it would connect the physical and mental domains as these have been traditionally conceived, okay? And let's look at once more, I already showed a little bit, but here you can see it better. So you see with classical fields, like the electromagnetic field, the potential depends on the amplitude of the field. It's like, of course, it's like the brightness of the light waves. Or if you think of a water wave, it's the size of the water wave that determines the effect the wave has on a floating object. But this quantum potential only depends on the form or shape of the field, not on its size or amplitude. And those of you with mathematics, you can see that it depends only on the second spatial derivative. So the situation here is imagine you have your floating object, your rubber duck, in a very calm lake. And in classical physics, with classical waves, if you want to kick the duck or make it move, you have to make big waves. The bigger the waves, the more the duck will move. In this situation, a very tiny wave can have a tremendous effect. So this quantum potential can be very large as long as there are interference effects, or you have a kind of a form of the wave that will give rise to this large value according to this simple equation. Okay? And so again, you see the idea is, so this quantum field, I mean, this is what Bohm started emphasizing. This quantum field is not pushing and pulling the particle mechanically like a water wave would push and pull a floating object. Rather, the quantum field literally puts form into or informs the particle to behave in a certain way. Here we are going back, if you like, to the original notion of informare. And the electron, so what we are saying here is that the electron is moving under its own energy that is being informed by the form of this quantum field. And then there are various ideas, they have various ideas where that the energy would be coming from. But of course, Bohm, he was a philosophical thinker. He was interested in not just the nitty-gritty, but these more general philosophical questions. And he suggested that what we see at the quantum level is actually an instance of a general feature of active information that we see operating at many levels of nature. And which is actually we have a lot of that even in common experience. And you see, so what's the basic idea? What's the naive idea here? Well, the idea is that a form that's carrying very little energy enters a greater energy, and as a result, the form of the greater energy becomes the same as that of the small energy, okay? And this is easiest to see in artificial devices. So and this is an analogy, okay? So when we have a ship on autopilot, which is being guided by radar waves, those radar waves are not pushing and pulling the ship, okay? What is happening is that the form of the waves, which reflects the form of the environment, you know, whether there's something in the bottom of the sea you should avoid or whatnot, this is taken up by the autopilot device and is used to direct the ship, okay? So this is a kind of an analogy. So, you know, it's like the Bohmian electron is a bit like this sort of ship. And you see, and the analogy is here, you see this quantum field contains information about the environment of the particle. For example, the slits. And so, so you see the way this works in quantum mechanics is that to get your wave function, to get this wave, you have to solve the Schrödinger equation, but to solve the Schrödinger equation, you have to tell you what the situation is. So you have to tell it about the equation whether one or two slits is open, and then the wave will reflect that. But of course, whether or not one or two slits is open is a fact about the macroscopic environment. So it looks here like the macro environment informs the tiny quantum object in some direct, immediate way. We're not saying there are some things interacting between the macroscopic slit. I mean, those can be centimeters, the slit device. You can have it in your pocket. Just, you know, the partition. And so this is something that I'll come back to a little bit later, that there's something in that sense very interesting here. And of course, some of you know from quantum mechanics, it's the relation of the macro and the micro. That's one of the key issues. Okay. And again, you see here, well, check, this is just to illustrate that if I do it here, will you see it? Oh yeah, sorry, I should have done it earlier. So for here, you can again see that what I mean by saying that these slits here can be macroscopic, and whether or not this one or two slits is open, it will then influence the Schrödinger equation and change the quantum potential. So that's just to repeat that point. Now, of course, you see, we could get many other examples of active information. I mean, of course, with computers, there's loads of information sitting there which can be activated. But then somebody say, oh, you're giving these artificial examples. I mean, come on, you know, the electron is not like that. But of course, when you go to biology, it's very common to say that things like the DNA molecule is a code, like language. It informs protein construction. The DNA molecule is not like pushing and pulling, or the order there is not determined by forces of classical physics. It's something that can be used as a code, and that is again guiding protein construction. That's information for the cell. It's not information for us. So we have to get used to it, because I think one confusion about information, we always think it's for us. We're so selfish, right? Whenever I hear information, it's for me. No, the DNA carries information for the cell, but we don't have to be depressed about this, because there is information for us as well, right? For example, when you're reading a map in subjective experience, so you abstract the forms that in your mind that will give rise to, oh, well, shall I go this way, that way, especially important in Siena, because, you know, there's no straight line from the hotel to here. But then, of course, at some stage you will select one route, and that information becomes now active and is guiding you. The poor electron hasn't got too much choice. It has, wherever it happens to be, it will obey this information. But in the human mind, you actually get a richer set of possibilities. So, I mean, this is just to give you an idea that this active information as such it's just part of our common experience. It's cool, but there's nothing very, if you like, crazy about it. But of course, when it does get exotic is when we try to extend it to the quantum level like Bohm did. And it could, you see, the whole thing here is that this might actually have philosophical significance to our notions of matter, and including mind and matter. And you see, well, again, to say that, I mean, this is how Bohm, and they already wrote about this in the 83 article, and they themselves acknowledge that this notion of a particle responding actively to information in the quantum field is far more subtle and dynamic than any others that have hitherto been supposed to be fundamental in physics. And this is one of the, of course, this may be one of the reasons that still in the physics community, physicists find these kinds of ideas difficult. There is a version of this Bohm's theory, which is called Bohmian mechanics, where they've kind of made a very sober version. So, because you see, people who are very like, who only want to see matter, who want to almost go back to Newtonian mechanics or whatnot, they might like the Bohm theory. And of course, then when Bohm himself start talking about exotic things like active information, then they don't like that. So if you like, David Bohm is the worst heretic in Bohmian mechanics. Just for those of you, if you start reading the stuff, you will know, you won't find much discussion of this. But from the philosophical point of view, I think this is the exciting part of the Bohm theory. I mean, the other stuff is okay too, but it's kind of maybe too sober for my taste. Okay. Here's just for those of you who worry about the Shannon information. So with Shannon information, the idea typically is it's a measure in which a state of system is uncertain to us. So if you like, the more surprise we get when we get the information, the more information there was, okay? Whereas here, Bohm would claim that the active information is not essentially related to our knowledge or lack of it, because this information that's relevant to determining the movement of the electron itself, it's information for the electron, or as the philosopher Dretske would say, it's information as an objective commodity, okay? So, and anyway, I mean, it's interestingly, those of you who know the integrated information theory of Tononi will notice that there could be kind of similarity between IIT, or integrated information, and this Bohmian information. In some ways, there are also differences, but you know, we discussed this with Tononi in recent years, and I hope to write more about that in the future. But okay, but before I conclude, let me just say that, you see, there is the question, well, how might this then be relevant to understanding mind or consciousness. And you see, one possibility, if we do so-called quantum brain theory in this model, of course, then what we say is that the little thingies in our brains are not just particles, but in some circumstances, they might have actually this Bohmian pilot wave alive and kicking. And anything that can influence the pilot wave can influence particles, and it can be amplified to action potentials, and so on and so forth. And of course, a lot of people like Penrose and Hameroff have tried to argue that in microtubules in the brain, you could have these quantum coherent states. And of course, then you can apply this thing there. In my view, this is why I think this Bohm's information view is a better quantum approach than the Penrose-Hameroff is, because I think the notion of information can easily be connected to mental states. Or, the brain is processing information, but also then, and from information we can then discuss whether, various mechanisms whereby information could become conscious. And so this is, I'll show you some articles if you're interested in this. We've been writing about this. I focused more on the physics part because in some ways I feel if you don't understand the physics part, you're not gonna read anything else either, because you just think, well, this is just something. So this was my strategy for today. But I do mention, one of the philosophers that I've interacted actually since late 1980s is Ron Chrisley. He's a cognitive scientist, philosopher in the University of Sussex. And he's been looking at this thing already, 30 years or more. And he actually did he did a paper on quantum neural networks. We were discussing the things in 90s. So this was one of the first ones, maybe published in 96. Using the active information, the quantum potential in that context. But then Ron was also, he wrote criticism of the work that Bohm, Haile, and myself were doing. One thing he was saying that if we want to say that active information is relevant to mental states and this kind of quantum active information, so Ron felt, well, and I was trying to suggest we might have sort of proto-intentionality here as a directedness. Ron was saying, well, to have intentionality, there's got to be error. And then I said, well, okay, how can we have error here? Maybe there would be a way of fooling the electron that two slits are open when there is not. So, some evil demon modulates this quantum field, and so the electron will misbehave, if you like, on the basis of misinformation. But I guess we left it at that. Because this is kind of, at some stage you feel, well, what can we say about these things? But we had this meeting, Physics and Reality, in Helsinki in early June. Ron was there, and he kind of went back to our old discussions. But he came up with this new idea. Because Ron has, of course, he interacted with Dan Dennett and, for example, has ideas about qualia. Of course, what people want to do is to coin qualia, get rid of qualia because we can't explain them. But now, Ron, maybe, he's getting wiser, he's getting older, who knows. He actually, let's turn it the other way around. And this is his proposal. This is quoting from his slide in Helsinki. What he was saying is that if our knowledge of our own qualia is somehow, by virtue of being informed by active information, then we could explain the actual immediacy, intrinsicness, and privacy of qualia. And Ron has argued elsewhere that ineffability follows from privacy. So, for example, immediacy. Knowledge of qualia is not mediated. It is not by virtue of contingently interacting with something else that the particle is informed by the quantum potential. And so the inability to find misrepresentation here is a feature, not a bug. Immediacy yields incorrigibility. And of particular note is that the particle can be directly informed about high-level, complex, classical features, namely the presence and location of slit. These things I tried to emphasize a little bit earlier on, how this works here. But somehow this idea is that, you see, you could have, what do we need for this? Why would we need any, okay, you can have as much as quantum information in your brain, but what does it do? As opposed to, let's say, classical or any other kinds of processes. And the idea here is to try to make use of the kind of immediate quality that seems to be there. And of course, I mean, this is, again, it's not just for, there could be implications here. You see, the properties of quantum mechanical information might help to understand our immediate access to our own consciousness. And of course, we know from Descartes that we cannot be wrong about the sentence, I think I exist, when we think of it. So there's this whole idea of incorrigibility in the first person perspective that's kind of built into our tradition. And so I already mentioned that quantum mechanics might save Descartes in the sense that maybe Descartes was correct about consciousness. Not everything needs to live in space-time. I mean, consciousness is more like what Bohm would call in the implicate order. And I've written about that in my book. But of course then, but it's not just ontology. Here actually the way Ron is proposing now, it might have radical implications to epistemology as well. So we'll see where we get with this. Maybe we thought we might make a joint paper or something like that, but waiting for that, here are some old ones. So anyway, thank you very much.
Thank you very much, Artem. And thank you for the organizers for inviting me to this exciting meeting. And let me start with a consideration that I am particularly honored to speak here because in this building, Santa Maria della Scala Hospital, maybe this is difficult to believe for most of us, but my generation of medical students started in this building to become doctors. We were at the end of the last, in the mid-90s of the last century, and me and other people here started our medical history just in this building. Here there were, as inpatients, many people in the rooms with frescoes that you will visit this afternoon. So it's very exciting for me to be here again after, let's say, almost 30 years to speak about consciousness and artificial intelligence with you as philosophers. My talk will be a clinical talk because I am a clinical neurologist. And I will try to explain you where we are with a complex story, which is trying to restore consciousness in people who have lost it due to lesions of the brain. So I will speak about a relatively new approach to this kind of disorders, which is neuromodulation. And you will see what neuromodulation is. When we speak about people who have lost consciousness, we have to put the story inside the physiological, our physiology. People could be fully awake. Okay, if we plot the level of consciousness, that is wakefulness, and the content of consciousness, which is awareness, there are some physiological possibilities. The first one is to be fully conscious, as I guess to be now, okay? And wakefulness is full wakefulness and full awareness, which is the same situation of particular patients called the locked-in syndrome, which have a preserved brain, an intact brain, but lesions in the upper part of the spinal cord, which preclude them to move, to speak, and to have relations with the external world. But they are fully awake, and they are fully aware to be awake. The level of wakefulness and awareness progressively decrease when we sleep. So drowsiness, light sleep, and deep sleep. and completely disappear, both wakefulness and awareness, when we are under general anesthesia or we are in coma. But fortunately, both of these conditions are reversible. We can wake up from general anesthesia, and most of patients can wake up from coma. It's a different situation in two other conditions that are disorders of consciousness, which is the minimally conscious state and the vegetative state, or what is called now unresponsive wakefulness state. Because these are patients that in which the level of wakefulness is relatively high, is present, but they have almost no awareness to be wake. And this is a very difficult condition to identify because of the difficulty these patients have to enter into relation with external world. They cannot speak, they cannot answer to questions of the doctors, and so on. The slide should go on, but okay. I don't want to enter into the debate of what consciousness is. I guess there is a problem with the pointer because it's very slow in, see? Yes, but il problema non è il laser, il problema è che non vanno avanti le slide, o perlomeno lo fanno in modo molto anarchico. Okay, I don't want to enter into details of what consciousness is, because there are, as you know better than me, many conflicting theories between each other, and probably, and there is not yet a clear response by a neuroscientific side about what consciousness could be. In a way that in a way that David Chalmers suggested to define consciousness as the hard problem, as you know better than me. From my side, as a clinician, restoring consciousness in patients who have lost it is an even harder problem, okay? And probably is the hardest problem of clinical neuroscience. We are trying to to give back something that we still do not know what is it. So the field is quite obscure. And the situation is particularly difficult to disentangle between patients in minimally conscious state and patients in vegetative state, because they are not able to produce motor behavior. So it's very difficult to disentangle by a behavioral point of view, by visiting at the bedside these patients, to understand in which of the two states they are. And this is particularly relevant in terms of possible therapeutic opportunity, as you will understand. And this is even an even greater problem because disorder of consciousness, when people due to a lesion is losing his consciousness, disorder of consciousness are very often entering into a prolonged state up to a permanent disorder of consciousness, okay? That may last for many months and even many years. And this poses big problems for, as you can imagine, for families of these patients and also for the health care system. So chronic disorder of consciousness is a challenging, very challenging clinical conditions. Also because we have to consider that the rate of spontaneous recovery in this kind of patients is quite low. It's about 20% in the first year after the disorder of consciousness has appeared. There is basically no effective pharmacological therapies for these patients, and then we will see why. There are some attempts with amantadine, which is a drug that has some dopaminergic activity. There is some attempt with zolpidem, which is a drug that has some GABAergic activity, but no real clinical demonstration of a clear efficacy. And of course, in this kind of patients, even very intensive programs of physical and cognitive rehabilitations have limited efficacy. So we badly need, we have an urgent need of alternative therapeutic strategies, and neuromodulation could be one of these. As we wrote with Dr. Regazzoni, who is present here in the room some years ago, before thinking to a neuromodulatory intervention, we have to satisfy some prerequisites. First, we must have an idea of where to stimulate the brain with electrical activity, with what I have called in a book, healing currents. We have to know which is the target of stimulation and which is the dysfunctional network or networks that we would like to restore to in its function to a more physiological level. We should be able, with our neuromodulatory intervention and treatment, to produce beneficial plastic changes in the brain, which of course outlast the period of the stimulation. And we have to be relatively sure that the effects that we are inducing in the brain with stimulation involve not only the target that we are going to stimulate, but the entire network to which the target is connected with. And this effect should restore at the end more physiological functioning of the dysfunctional network, thereby obtaining the clinical improvement. So it's really a hard task. And which are the techniques that we as neuroscientists have available for treating, for attempts to treat these chronic conditions? We have a set of techniques that could be extremely invasive, that require a neurosurgical intervention. The positioning, the name is deep brain stimulation. We have heard yesterday in a relation about this. In this case, some electrodes are placed by the neurosurgeon inside the brain, and we will see later. Another invasive technique is stimulation of the posterior columns of the spinal cord in the attempt to stimulate the brain, the sensory regions, primary sensory cortex on the brain. And we have a set of non-invasive techniques which are called transcranial magnetic stimulation, transcranial electrical stimulation, and transcutaneous vagal nerve stimulation. I will explain briefly the mechanism of action of these techniques during my talk. But let's say another thing regarding the difficulty to treat these patients. Why it's so difficult to treat these patients? Because chronic disorder of consciousness represent a model of thalamocortical disconnection due to a lesion that could be an ischemic, hypoxic insult after a cardiac arrest, or, for example, carbon monoxide poisoning. There is a strong disconnection between the cortex, the gray matter, okay, and the subcortical structures as thalamus. So there is these lesions render any structurally intact cortex unable to function because connections between different cortical areas via the thalamic nuclei are no longer functional. So it's difficult to think in the frame of a disconnected brain that stimulating one cortical target, let's say, the stimulation will really reach the rest of the brain. And this is clearly evident also from modern neuroimaging techniques. This is an image of white matter, and you see the density of connections in a healthy brain, and the reduction of connections in patients with disorder of consciousness due to a traumatic brain injury or an ischemic hypoxic insult. There is also a reduction of fibers connecting not only the thalamus to the cortex and vice versa, but also the two hemispheres and distant regions in the cortex. Disconnection syndrome is now possible to directly verify if a region of the brain is disconnected from the rest of the brain, thanks to a technique, a neurophysiological technique, which combines transcranial magnetic stimulation and electroencephalographic registration. This is a technique relatively young, which was introduced in Helsinki from Professor Risto Ilmoniemi. And it's very important because it allows to verify if the patient that we are going to stimulate maintains some level of connectivity, intact connectivity between the point of stimulation and the rest of the brain. This is a patient under general anesthesia, I think, and you see that if you give a magnetic pulse on a given region of the brain, you get no response. In this case, which is a patient in a chronic vegetative state, stimulation of one region of the brain gives rise to a very a single response, which has no complexity. But if you stimulate a given region of the brain in a patient in a minimally conscious state, the level of complexity of the response is higher. This does not mean anything in terms of what consciousness is, but is a direct information of the residual connectivity of the cortical region that I am stimulating. So the more is the complexity of the response, the more preserved is the connectivity of that brain. So in this case, there is some chance that a neuromodulatory intervention could restore more physiological activity in that brain. So the first question that we have to answer is if we want to neuromodulate a brain with a disorder of consciousness, where should I stimulate? Which is the target to be chosen for a good neuromodulatory intervention? Some time ago, we did a meta-analysis of all neuroimaging studies performed in patients with disorders of consciousness. Lucia Mencarelli did a very hard job screening almost 600 neuroimaging studies, and she put together in a with this method, activation likelihood estimate maps, the results of all previous neuroimaging investigations. And what we found was that during resting state, analyzing these studies during resting state, when the brain is not engaged in any task, we found that a convergent result was a deactivation of deep nuclei, thalamic nuclei, and of middle frontal gyrus and angular gyrus, with a very good degree of overlap between patients that were in vegetative state and patients in minimally conscious state. Indeed, the thalamus, we will see, is one of the main targets selected for neuromodulation, for invasive neuromodulation in this kind of patients. And at the level of network, the most involved one in terms of deactivation was the default mode network. Which are the possibilities to stimulate this brain? Let's start with a less invasive technique, which is repetitive transcranial magnetic stimulation in its repetitive mode. Through the coil, which is placed on the scalp, we are able to deliver magnetic fields to the brain that, for a physical principle, it's the Faraday law, revert into an electric field inside the superficial layer of the cortex. Okay, so it's a way to bring electricity into the brain from outside in a completely non-invasive way. And depending on the combination of the frequency and intensity of stimulation, the repetitive TMS produce long-lasting modification of synaptic efficacy that could be or excitatory, inducing long-term potentiation mechanisms at a synaptic level, or inhibitory, inducing long-term depression at a synaptic level. So with TMS, we are doing on the brain what a drug is doing. Even drugs acting on the central nervous system usually act at a synaptic level, but without side effects, because we can target the stimulation where we want, on the target we want, on the network that we want. It's a completely different story from electroconvulsive therapy. Here there are some side psychiatrists in the room, and I would say that repetitive transcranial magnetic stimulation is a different word from electroconvulsive therapy. We don't need to induce a seizure. We don't need the patient be anesthetized. The patient is awake, and we are not inducing severe side effects, as, for example, disturbances of episodic memory, okay? That is a very frequent side effect of electroconvulsive therapy. What has been done in chronic disorder of consciousness with TMS? The first study was done here in between Florence and Siena some years ago, and we got, I will not enter into technical details of the studies, but just to show you that the first study was basically negative. We tried to restore consciousness in a small group of 11 vegetative state patients. We got some electroencephalographic reactivity under the point of stimulation, which was the primary motor cortex, but we get no clinically useful results. But what emerged from this first pilot study was a clear difficulty in rating the effects of intervention of these patients. There was a big discordance between the clinical rating made by physicians and clinical rating made by the familiar of the patients, with a great degree of discordance. And this is an important point. After this study, a lot of randomized clinical trials based on repetitive stimulation followed, and basically what we can say, okay, the technique of neuromodulation is safe. There were no adverse effects. That longer is the period of stimulation, better is the results. But the improvement that, the little improvement that in all studies was found corresponded to a less than 2 points of the coma recovery scale, which is a clinical metric to measure the state of these patients, which in terms of recovery of consciousness means almost nothing. The problem was that most of these studies, of these randomized clinical trials, were performed on patients, on very severe patients, on vegetative state patients, on unresponsive wakefulness syndrome patients that, according to what we said before, have a disconnected brain. So there is conceptually no reason to stimulate a part of the brain which is not connected with the rest of the brain. So very few studies on minimally conscious state patients. Another technique that has been used, another non-invasive neuromodulatory technique that has been used in these patients is transcranial direct current stimulation, which is the delivery of small currents to the brain in terms of 2 milliamp maximum. So these are currents that are almost imperceptible by patients, even if patients would be awake. And how it works? It works in terms of modulation of the possibility that the neurons of the cortex could modify their level of firing. In this way, if this is the baseline neuronal activity of a group of neuron. Each vertical spike you see is the neuron that is firing. And you apply an anodal current, okay? The spontaneous firing rate of this neuron is increasing. So you are producing an excitatory effect on that neurons. If you apply a cathodal current in this way, the probability that these neurons is firing is reduced. So you are inducing an inhibitory effect. In case, and in any case, you are performing a neuromodulation of that neuron or that network, because this kind of stimulation can be directed to the entire network due to some technical advancement. In case of disorders of consciousness, the direct current that has been used is always anodal in the attempt to re-excite to these neurons to more physiological levels. Initial attempts were based only on a single session of stimulation with some positive results, but what appeared clear was that the clinical response to transcranial direct current stimulation depends on the residual brain metabolism and gray matter integrity in patients with minimally conscious state. Quindi again, it's possible to modify something in patients with minimally conscious state that have some residual function, residual connectivity in the brain, but it's very difficult to think to apply these techniques to patients in a vegetative state. There are some other studies in very well conducted studies in terms of randomized controlled trials, all using anodic excitatory stimulation. And the largest of the study, unfortunately, was it's a multicentric French and Belgian study on more than 60 patients, okay, that underwent to stimulation with transcranial direct current stimulation for 4 weeks, 4 consecutive weeks. But as you can see, the trial was interrupted for futility, so no clinical effect. But a more in-depth analysis of these apparently negative results showed that patients that had the disorder of consciousness after a traumatic brain injury and that were in minimally conscious state showed some positive increase of the coma recovery scale. Again, not sufficient for restoring them consciousness, but some sign of improvement. So again, there is probably some possibility in patients with minimally conscious state when when the brain preserves some residual activity and the target is connected with the rest of the brain. Let's skip spinal cord stimulation and let's speak about deep brain stimulation, which is an invasive technique through which we are able to insert some electrodes inside deep structures of the brain, and these electrodes are connected through subcutaneous cables to an internal pulse generator, which provide currents to these electrodes, healing currents to these electrodes, and these currents are able to dramatically improve some neurological signs in Parkinson's disease, in tremors, for example, of various origin, in dystonia, also even in obsessive compulsive disorders and in drug-resistant epilepsy and depression. So this is especially for neurological disorders as Parkinson's disease, tremor, and dystonia. It's the gold standard for treating advanced diseases. When with drugs alone, we are not able to give a satisfactory quality of life to these patients. DBS has been tried in chronic disorder of consciousness, but before showing you the negative, unfortunately, results of DBS in chronic disorder of consciousness, I want to show you how much DBS could be efficacious beyond the effects of drugs. This is a young, not young, sorry, a 66 years old woman that we have operated the last week in Siena. She is affected by tremor, and you see that she is able to draw this spiral when the DBS is on, when her electrodes in the brain are active.
Here.
And this is what happens when we switch off the currents of the DBS leads. She is not able to draw the spiral, and you can imagine this woman, for example, bringing a glass of water to her mouth. She is not able to drink, of course. And with drugs, we were not able to modify this pathological condition. And this is an example of
See important safety
an
information at the
example
end of the video.
the
Only your
effects
doctor can
of
determine
deep
if this
brain
therapy is
stimulation
right
in
for
a
you.
severe form in advanced form of Parkinson's disease. In this case, the patient has electrodes located within the subthalamic nucleus bilaterally. This is the patient in off stimulation. You see she is very slow, very rigid. The walk is difficult. In this case, there is no tremor, but great difficulty, for example, for turning on at the end of his walk. Può andare avanti un pochino con il video? And on this side, you see the same patient when the DBS leads were turned on. Ancora un po'? Ancora un po'? Ecco. It's difficult to think that this is the same patient. Without drugs, only with the electrodes in the brain switched on. Okay, so this is just to show you that DBS is really an effective therapy in some neurological disorder. What happened in disorder of consciousness? There have been some attempts. About 150 patients treated with DBS, but all of these studies were based on very small case series, no randomized controlled trials, with and electrodes were always placed in the thalamic nuclei, and you remember that the thalamus from the meta-analysis was the less active part of the brain. So the attempt was to put electrodes inside the thalamus in the attempt to restore a more physiological drive to the cortex. But again, the problem was that in these patients that were all vegetative state, almost all vegetative state patients, the thalamus was disconnected from the cortex. So it's a conceptual error, in my opinion, to think to DBS in these patients is if there is no anatomical integrity, no anatomical substrate for the currents delivered on the thalamus to reach the cortex. These studies were performed mainly in Japan, and if you go deep into these papers, you see that the way to judge the clinical effects is quite obscure. So results, in our opinion, I guess that Dr. Ragazzoni will agree, is not really reliable. A recent paper reported the experience, a long-term experience of deep brain stimulation in disorder of consciousness of a single center, but this was really a good study. All patients were selected to undergo deep brain stimulation if neurophysiological investigations, evoked potential investigations, showed a residual functional and structural connectivity between the thalamus and the cortex. So it's a conceptual step ahead on what we have talked up to now. In these patients, the stimulation was unilateral. Only one side of the thalamus was the target. And the electrodes were all implanted in this particular part of the thalamus, which is centromedian nucleus. On 32 patients, but followed up for 10 years. Briefly, what happened? Happened that younger patients, you see the age of the patients is very young here. 7 younger patients on 32 patients recovered their level of consciousness. Not only one patient came back to be independent in his life, but this has been the first study that showing that if the patients are well selected, if they have a preservation of thalamocortical connections, and if they are in a minimally conscious state, then DBS could be a promising approach. Promising but risky, because 5 of these patients died after the implantation. They were all unresponsive wakefulness syndrome patients. In 3 patients appeared seizures that were not present before. 4 patients had hypoxic myoclonic jerks and other minor complication. And another issue to be considered is that in all patients, for ethical reasons, the DBS lead was removed after 3 years. So the question is why performing a complicated neurosurgical intervention in a patient that will likely undergo to some severe complication, and then after 3 years I had to remove the electrodes. We have to think about it. And I'm going to finish. There is another conceptual problem, in my opinion, thinking at deep brain stimulation in these patients. You have seen very good effects of DBS in Parkinson's disease and in tremor. But in these cases, we use DBS as an interferential approach to a pathological hyperactivity. in Parkinson's disease, for example, there is a pathological oscillatory hyperactivity of the subthalamic nucleus, which sustains the rigidity and the bradykinesia. And when we perform DBS in these patients, we are inducing a sort of jamming effect in this pathological hyperactivity for restoring a more physiological oscillatory activity. So with DBS, we are basically perform a functional lesion of an hyperactive circuit. In case of disorder of consciousness, according to people performing DBS in these patients, the DBS should act not as a functional lesion, as is demonstrated that is the case, but in a completely different way, for reactivating a dysfunctional circuit. And this is a conceptual critical problem, in my opinion. Then, of course, another issue is to really think very, very deeply at when DBS should be performed. So not too early, because the rate of spontaneous recovery could be could peak up to 50% at 1 year, especially in post-traumatic brain injury. So maybe one could think to DBS after 1 year of chronic disorder of consciousness. It's difficult to evaluate the effects of DBS in a patient that has no possibility to communicate. And this is another problem, including the distinction between the induction of some unspecific arousal versus a real and persistent clinical effect. We have said about ethical and ethical aspects, okay, including the possibility of inducing severe side effects. But the most important point is that and this is true in my opinion for any kind of neuromodulatory intervention, is that the patients have to be selected on the basis of very very well conducted neurophysiological investigation in order to show that there is some residual integrity in terms of connectivity in the brain that we are going to neuromodulate. And for this, we have to use the combination of TMS and EEG, as we we have seen at the beginning of the lesson, and that is called the perturbational complexity index. And of course, we have to base on findings of functional neuroimaging investigation. Only in these cases, when the patient is well selected, as happens for neurological disorders or for psychiatric disorders, then we can proceed with a neuromodulatory intervention. And finally, this is the last slide. I am in time? Okay. The last slide is that what we need is even a better dissemination of results, because if we analyze a relatively long period of 10-year period, there are almost 400 articles appeared in the literature using as keywords disorder of consciousness and neuromodulation, but only about 20 papers are published on Q1 journals, which means that most of this literature is appearing on predatory journals and journals that in which the peer review way for reaching a publication is probably less selective in general. So I guess for conclusion that maybe there is some room for neuromodulation in disorder of consciousness, even considering that we have no other alternative, reasonable alternative therapeutic strategies, but we need a strict selection of patients, which is the most important thing, and more in-depth critical analysis of results in terms of clinical effects. Thanks for your attention.
Thank you very much for this invitation to speak in my own town. I hope that I have taken the risk to be Nemo Profeta in Patria. Well, but this is a joke. Well, the title of my talk is Consciousness a Higher Order Property of the Brain Dynamics? A naturalistic philosophical approach to this hypothesis. This hypothesis is very ambitious. I'm afraid to say that as a matter of fact, as a philosopher, I am not a mathematician, I am not a physicist, I am not a cognitive scientist, etc., etc., etc. And therefore, I understand the point of view of a poor goofy who says all this variety of theories of consciousness is confusing. Nevertheless, says Goofy, but I still know I am awake. In this moment, I'm sure that I am awake. Well, of course, this is a second joke. But seriously speaking, I think that I would like to give a bridge, to throw a bridge between common sense, the common sense of a Goofy, and the very sophisticated, very technical theories of consciousness offered by, we have seen also today, by physicists, by neuroscientists, by computer scientists, etc., etc., etc. Well, as a philosopher, what can I do? I believe in the continuity between philosophy and science. But I don't think that the philosophy is a cognitive science. Philosophy is neither science, nor art, nor history. Philosophy is simply philosophy. That's period. But therefore, the philosophy mind without the cognitive sciences is empty. But sometimes I have the impression that cognitive sciences without a bit of philosophy mind sometimes become blind or at least a bit myopic. Well, therefore, traditional philosophical solutions to the mind-body problem, this is the physicalism is the first solution most in agreement with the cognitive sciences. This is the pars destruens of my talk. I don't dare to say that I'll prove that all these theories, traditional solutions to the mind-body problem are all false. But at last, I would like to make clear what are the theories whose rejection is a presupposition for my position. Okay, in this way you have the possibility to have clear what you can have objections. Well, this is the past destruence. The past instruence or constituents is a sketch of an interdisciplinary physicalistic ontology, quasi-theoretical framework, suitable for the development of the cognitive sciences. From these two premises, I'll try to get a conclusion. The conclusion is that the hard problem of Chalmers, etc., is, as a matter of fact, a pseudo problem. It is hard to give a scientific solution to it, but it can be dissolved through a philosophical clarification. First of all, the first theory that I reject is interactionist ontological dualism. You see, I am in front of a traffic light that is red, and there's a certain causal chain of physical events. At the end, I push a pedal, and I stop the car. Well, according to ontological dualism, and dualists are often also libertarians, they say if this causal chain is continuous, then the motor response is no intentional action, is only a reflexive. But in this case, since the action of stopping the car is an intentional action, according to ontological dualism, it's necessary that there's at least a gap in the physicalistic causal chain, and this gap is overcome by a spiritual bypass. That is, my brain produces a certain perception of the traffic light. This perception produces the decision to stop the car, and this decision produces a certain activity of the brain, at the end produces the motor response. Well, what is the problem with this interaction? The problem is the second error, because if the mind can interfere in the causal course of a physical events, then there's a clear violation of the causal closedness of the physical world. I know that this is a huge discussion about that. First of all, what we have heard today, tomorrow, about the interactive information, etc., this has nothing to do with this hypothesis, because in this hypothesis, the mind is a level of reality metaphysically different as the physical world. And therefore, if in the hypothesis that there are microphenomena that determine certain macrophenomena, well, this happens in the physical world, and therefore we are in a physicalistic hypothesis, not in a dualistic one. Therefore, I think that the violation of causal closeness of the physical world is not only an epistemological principle, but according to me, I know that this, I take a risk because physicists could have many objections, but I think that this is a violation of a physical principle. That is the first principle of thermodynamics, that is the principle of the energy conservation. Because if something happens in the brain that is not caused by other physical events in the brain, then you have an event that consumes energy, and this energy doesn't come from other physical events, but comes from another level of reality. And therefore, you have a small, but in principle, an important violation of the energy principle conservation. Well, of course, there are other spiritualistic solutions or divine body problem that are monistic. For example, idealism. Idealism, you see, in a certain sense, esse perché qui is been perceived or been thought. George Berkeley or Kant or Hegel in different ways, according to different kinds of idealism. But in any way, there's something that is, according to me, is unfalsifiable. This is the idea that the world isn't a reality that is independent of our knowledge is an hypothesis that is unfalsifiable, that is unscientific, and too strongly anthropocentric. Parallelism and neural monism. Well, here the things are more complicated. The idea is that the idea comes from Spinoza and then from Bertrand Russell in an empiricist formulation. The idea is that mind and body, the physical world and the mental world, are two manifestations of the same thing, substance. Well, the problem, we can say that the mind and body are two sides of the same coin. The problem with this hypothesis is that if you suggest this hypothesis, you have the duty to make clear what the coin is. And I haven't found no satisfiable response to this question. Neutral monism, therefore, is a hypothesis that explains obscurum per obscurius, the obscure by means of what isn't more obscure. Epiphenomenalism, epiphenomenalism has no problem with empirical data. You see, in this case, the causal chain, the physical causal chain, from the distal stimulus to the motor response is continuous. The problem is, in this case, the epiphenomenalism, that there is a kind of a dualism. It's an error of Karl Popper to say that epiphenomenalism is materialism. No, epiphenomenalism is a kind of a dualism. But in this case, we see that the brain produces mind, but the level of mind is completely useless. And therefore, from an epistemological point of view, this hypothesis can be excluded because it falls into Occam's razor. Occam's razor is entities should not be multiplied unnecessarily. Ence non sunt multiplicanda praeter necessitatem. Well, some philosophers have said, well, according to, if ontological dualism doesn't work, ideas doesn't work, neutralism doesn't work, then maybe we can think that the mind and body appear to us as different things, not because they are different things. We don't know nothing about that. But we can say that there are different things. They appear to us as different things precisely because we can only know them through different and independent methods. Well, for example, Wittgenstein and the Wittgensteinians distinguish between reasons and causes. The reason why I'm raising my arm is to give you an example of an intentional action. But in this moment, while I'm raising my arm, my brain raises my arm. That is, for example, von Richter, the most famous neo-Wittgensteinian, has written, it is important here clearly to see the different nature of the causal explanations of the movements and the reason explanations of actions. A reason explanation is of an action. A causal explanation is of the physical, somatic aspect of an action. Therefore, von Richter concludes, my action of raising my arm is free. is intentional, is free. Whereas the movement of my arm is necessarily caused by certain neurological causes. But how is it possible that these two things go to... There's a clear parallelism between the action of raising the arm and the movement of rising, of the arm that is rising. But if the reason for my action are independent of the neurological causes that move my body, why my arm rises under normal conditions, of course, if it's not paralyzed, etc. If I freely decide to raise it, why is there such a psychophysical parallelism? We can either deny this parallelism. This, for example, is the position of Wittgenstein. Wittgenstein said clearly that there are some psychological states that are not correlated to any neurophysiological process. Is this possible? I think that no neuroscientist would say that this is possible. Well, the parallelism between the reason why we act in a certain way and the neurological causes of the bodily movements that implement our actions can be explained once interactionist dualism is excluded, only if you admit that the mental reasons for our actions ontologically coincide with the ontological causes of our bodily movements. Mental states such as intentions or beliefs are brain processes described in a psychological actionistic language. Well, this means that we have to take the bull by the horns. The only serious alternative to dualism, etc., is physicalism. And I show that physicalism is also eliminativism. Eliminativism is no alternative to physicalism. In this case, you have to renounce, to reject the hypothesis that the mind exists. Not in the sense that the mind is useless, that there are no mental states that cause our action, but in the sense that the mind is not an independent level of reality, but is implemented by neurological processes. The mind is in the brain. Therefore, the best course of action is to reject the existence of a realm of reality, the mental reality, that is ontologically independent from physical reality. Oh, why physicalism and eliminativism? Well, contrary of a very widespread opinion, eliminativism, there are many kinds of eliminativism. The most important one is the eliminativism or the eliminative materialism of Paul and Pat Churchland. Well, I have heard, for example, in my ears, Chalmers to say, oh, according to the Churchlands, we are all zombies. False. Paul and Pat Churchland have clearly said that with regard to consciousness, they are physicalists and not eliminativists. And Pat Churchland has repeated this here in Siena 20 years ago, when he said something more. He said, well, maybe it was an error of me and Paul to call our hypothesis eliminative materialism, because this caused many misunderstandings. Well, therefore, the eliminativism is the idea that what the church want to eliminate is not the existence of a consciousness, but they want to eliminate the concept, a false concept of a consciousness, and by eliminating this concept, they eliminate the inexistence reference of that concept. But if you say there's no, this is the example by Pat Churchland. If I say that there's no fire that is common to the sun and to a flame, well, we don't deny that there's two sources of heat, but the source is a phenomenon of nuclear fusion. The other one is phenomenon of oxidation. But do you eliminate the sources of heat? We are denying that both the sun and the flame can give to us heat? Of course, no. They wanted to eliminate a false conception of consciousness, not consciousness. But the fundamental objection to physicalism is that there is prima facie an irreducible conceptual difference between mind and body, thought and matter. This is a Cartesian intuition that not only philosophers, but many people accept. The problem is, how is it possible to reduce a state of a consciousness and more generally mental states to brain processes? This seems unintelligible. This seems contrary to common sense. Well, the first solution is given by Pat Churchland. Pat Churchland distinguishes macrophenomena, mental phenomena as macrophenomena, and microphenomena, that is brain processes. The baseline characterization of scientific reduction is tied to real examples in the history of science. Most simply, a reduction has been achieved when the causal powers of the macrophenomenon are explained as a function of the physical structure and the causal powers of the microphenomenon. Of course, there are a lot of hybrid solutions. The most important hybrid solution is functionalism. There are many different versions of functionalism, but the central idea they share is the insertion of an intermediate level of discourse, a sort of interface between folk psychology and cognitive neuroscience. This level of discourse, to which cognitive psychology belongs, describes the body-mind relationship in functional terms. Like here, I have no time here to explain the title. But you see that the first description is a description of psychology, where an external event causes a certain perception, the perception causes a certain decision, the decision causes a certain action. Through a functional reduction, you see that the perception, the other mental states, are reduced to a flow chart where there are many functions but these functions are implemented by biological processes, by neural processes. Of course, since the same functional state can be implemented by different brain processes, this has produced a certain objection to physicalism. That is the famous objection of the multiple realization. But I'll show you that there's a response to this objection. Essentially, functionalism is a form of epistemological dualism compatible, that is the level of analysis of a cognitive science and the level of the cognitive psychology and the level of analysis of a cognitive neuroscience, is a form of epistemological dualism compatible with physicalism. It's compatible, but as a matter of fact, this hypothesis is it excessively separates cognitive psychology from cognitive neuroscience. Many psychologists say, well, when I have described the flow chart of a certain phenomenon, I'm not interested in the problem of how this flow chart is implemented in the brain. This is a problem of the neuroscientists. But as a matter of fact, if the neuroscientists and cognitive psychologists don't work together, it's difficult to find out a successful hypothesis. Well, the other form of a hybrid solution, very widespread nowadays, is emergentism. That is, there are some dualists that say, no, but mental states, you are right, they say to physicalists. Mental states are produced by brain processes, you are right. But these mental states, after their emergence, are capable of acting back on the brain. Well, I think that this hypothesis is a trick, is a rhetoric trick, because it confuses three kinds of different form of dualism, of emergentism. First of all, there is a physicalistic emergentism. Mental states are higher order properties of brain dynamics under a psychological description. You know the bridge principles that connect the systemic properties to the local properties. For example, heat emerges from as a average kinetic energy from the vibration of the single molecules. Well, this is a kind of emergentism completely compatible with physicalism. It's physicalism. Then there are a functionalistic emergentism. Mental states are virtual states implemented by brain processes, but it is like in the first hypothesis. But we don't know any bridge principles. Somehow can brain processes implement mental states, but we don't know exactly how. Then there's a third form, the most widespread form of emergentism, a dualistic emergentism. Mental states, although produced by brain activity, once emerged, constitute an autonomous spiritual reality capable of causally acting back on the physical world. Therefore, in this way, they say, but we agree with you, physicalism, but then there's something more. Well, this something more is dualistic, and therefore all the objections against dualism are also against the dualistic emergentism. Well, now I have to. My idea is that, first of all, I distinguish, I accept scientific realism. Every scientific theory has its ontological commitments. But I distinguish between order of discourse and levels of analysis. For the fundamental point is that in the regimentation of a theory, regimentation according to the method of Quine, existential quantifiers must be indexed to the order of discourse to which they belong. Therefore, the result is, for example, that you can distinguish abstracta lata, and I add the category of ficta. For example, in this case, you can say that everything that is done by Han Solo was done by Harrison Ford. In this case, Han Solo is a virtual entity, completely implemented by Han Solo. But this is not valid for the Millennium Falcon, because there's no Millennium Falcon in the set of the movie. And especially this is valid for the jump into hyperspace, because the jumps into space are not physically possible. What is possible what we have here? We have only a trick. These stream arts are a symbolic representation of the jump. Be careful. The existence of the jump in the world of Star Wars is a necessary illatum. It's necessary. Without the jumps, the story of the movie doesn't go on. But and therefore, in that world, in that fantastic world, jumps are real. But is a reality indexed to that world. Whereas, from the point of view of the implementation in the physical world, whereas Han Solo has an implementation, the jumps have no physical implementation. What is implemented is only the trick that generates the illusion. Therefore, the trick that generates the illusion is real. But the jump is only a fictum. Well, if you apply this, all these conceptions to the relation to the interpretation of this fact, I think that we must distinguish three kinds of phenomena: intentionality, self-awareness, and consciousness. Let's say, I see that the traffic light is red is a single conscious perception where three different phenomena are fused. The first one is that I see that the traffic light appears to me to be red. The second phenomenon is the self-awareness. I know that the traffic light appears red to me and not to another one. And the third factor is that intentionality and self-awareness are invested, as it were, in a format of consciousness. If we distinguish these two things, we have the possibility to distinguish, for example, with regard to the redness of the traffic light, three things. First of all, the traffic light is red, means there's a distal stimulus that produces electromagnetic waves of a certain length. Then this red with asterisk is not the real object, but is the intentional object, is how the traffic light appears. Well, this appearance can be transformed by the so-called adverbial transformation in redly seen. That is, if I see red, the red is the object of the perception. If I see redly, the object is transformed into a wave of perceiving. And therefore, the wave of perceiving, whereas the physical implementation in the brain, in the activity of the brain, of an intentional object that can exist or not exist is very difficult. The content of the perception is not the quale, as content of the perception is not implementable. But seeing readily becomes a part of the form of the perception. And this form can be implemented by a brain process. Because it's if seeing a certain a certain train of signals, the modulation of this signal, for example, by the release of a certain neuromodulators, the modulation of this signal can implement seen readily. Okay, and therefore, the functional reduction of the description of false psychology in the description of a cognitive psychology and then of the cognitive neuroscience requires that the objectivity of the perception becomes a way of modulating this perception. I have no time to show locks that I have prepared, but this is an image of Brigitte Bardot. On the right side, you see a certain sequence of symbols, of letters. These two images seem to have nothing in common. Well, in a certain sense, these two images are two different representations of the same content, because the first image I have obtained by opening a certain file in the hard disk by the right program as a file with extension JPG. But if you open the same file within Word, as if it were a file with extension doc, then you obtain this series of letters. This is only a very small fragment of the entire file. But in a certain sense, the difference between the two files is not in the content, is not in what is represented, but in the modality of representation. And my hypothesis is that consciousness is not a property or a thing that belongs to a level of reality that is metaphysically distant from the physical world. No, consciousness is a brain activity, but is the trick by means of which is created the illusion that there's something more than the physical world. That is, consciousness is a format. Consciousness is not in the image where I see that the traffic light is red. Consciousness is not in what I'm seeing. It's part of the way in which I represent what I see. Therefore, there are many other things, but I must say something about therefore, consciousness is real. Is real as that part of the modulation of neural processes that creates the illusion that there's consciousness. Well, and the ego, well, in this case, I think that this is not real. This is a fictum. Because there's a certain activity of the brain that coordinates other processes, and the brain represents to itself also this activity. The representation of this activity is the image of offers an idealized image of the self. This idealized image of the self is the ego. As if in an orchestra, you see, this orchestra plays with an empty podium. But I have imagined that the single players, by looking at the other players, etc., constructs in their mind the image of the absent, of an absent director. Well, the ego is in certain sense the absent director. And therefore, the conclusion is that I feel like the helmsman of my body. This is a famous hypothesis of Aristotle. But this is an illusion. In reality, I am just a servo mechanism of the helm. And the helm is an impersonal process. But the illusion that I am a permanent ego is an essential part of the very servo mechanism. Moreover, the servo mechanism selected by evolution to improve sensory motor coordination has become, by exaptation, you know what neo-Darwinists mean, a rebellious servo mechanism because it has been reprogrammed by social life through the proliferation and replication in my brain of a cultural memes. To sum up, if following Descartes, we separate the mind from matter qua two levels of reality irreducible to each other, then later their reintegration becomes impossible, and the mind-body problem becomes an intractable hard problem. However, the dissolution of this mental cramp is immediate if one considers that our feeling awake, that is, our consciousness, is fundamentally and internal to the brain's functioning. I know that there are other hypotheses about that, but I think this. When that phenomenon is translated into neurological terms, the conscious format is lost, just as the Italianism of Peter's verse is lost when I translated it into English. Similarly, the subjectivity of the ego is lost when it is reduced to the process that implements itself. This, I mean, for example, in this example, dov'è? No. Ecco, let's take this verse of Petrarch. Chiare, fresche, dolci acque. Pronounced in Italian, you hear there's an alliteration, chiare, fresche e dolci acque. This alliteration and a certain liaison in chiare, fresche, dolci acque, this gives the sound of the river, of the water, or the stream of the water. Well, of course, in the English translation, this Italianness of the verse is lost. Clear, fresh, and with water. The denotation is just the same, but the connotation is different. Well, of course, I have lost Italianity or Italianness, but this was not the fact of the translation. This was the goal of the translation. Just the same for to be or not to be. And Vittorio Gassman said, essere or non essere. Maybe an Englishman thinks that something is lost in essere or non essere. Something that is included in to be or not to be. Well, of course, in this sense, it's normal to lose consciousness if you describe it in neural terms. But this does not mean that consciousness is something more than neural. The conclusion is that when I am awake, I have a certain feeling. This feeling is a physical phenomenon. Life is a physical phenomenon. Also, nuclear fusion is a physical phenomenon. These physical phenomena are completely different to one another. Well, but nevertheless, we think that are all physical phenomena. And this is my conclusion. Thank you.